Alright, my name's Case. I'll be doing problems 5 through 7. So we have an arm ABC here, which is connected by pins to a collar B that can slide side to side, and a crank C that can rotate about D. So first I started out by just sectioning it off and looking at just ABC to start. So when looking at ABC, we only have 4 actual forces. We have P, B, Y, since B can slide left to right, and CX and CY. Taking the moment about C, we can solve for BY using P and BY. So we get our BY value, and then after that, we can see that in the X direction there's only 2 components, CX and P, so they should be equal. So since we know P, we know CX now, which is 240. And for FY, same thing, only 2. Since we just solved for BY, CY is equal to BY, so now we have CY. So we have CX and CY. Using those values, now we can look at the component just at CD, and we just have the component CY and CX. And if we take the moment about D, we just solve for CY and CX, and plugging in our values, we get that it's 195 Newton meters clockwise. And so 7 asks, okay, what if that force is actually 280? So doing the same process, we can solve for our new BY value using our 280 value for P. We get our new BY, which is also our new CY value. And doing the moment about D again, we plug in our CX, CYs, and we get 227.5 Newton meters clockwise.
Alright, hey, I'm Evan. I'm going to be doing problem 3. So for this one, we're trying to find forces AD, CD, and CE along this truss. We can start this off by looking at the entire structure and then making a moment equation off of that. So for that, all we have to do is take the forces we know and then their perpendicular distance to point K. So we'll put that together and we'll set that equal to BY times the entire distance, because B is right here, so it's the entire length of the truss. We can solve for BY with that and then get 6.6. Then we can set up 2 force equations, one for the X direction and one for the Y direction. And with those, we can solve for CD with respect to CE. So now we got CD is equal to CE minus 14.03. We can then set up a second moment equation, solve that for AD, which is another unknown, and we'll get a negative value for that, and a negative value for these means that it's a compressive force. We then go back to our FX equation and we plug in our values, and then we can now solve for CE. We get a positive force for that one, which means it's a tensile force. And then now that we have CE, we can go back to CD with this equation, and we'll find actually that CD is equal to 0.
I did number 8. So this one we're given this it's a welded collar system, and so everything here is given. So we're given this angle of 30 degrees, and we're given our P force. And basically what we're trying to find is the couple moment required to hold this system in equilibrium when it is at 30 degrees. So the first thing I did was draw a free body diagram, see all our AY, AX forces, because we're going to need those for our net FX, net FY, and net moment equation. And the first time I solved this problem, I was trying to find the moment about A, which is kind of like what we want at the end. But when you just jump straight to that, it's like you have too many unknowns and you just can't solve for it. So I was discussing with some classmates, and we decided that it would be better to just get the moment about B, which is actually the same thing because it's a reaction moment in this system.
So like when it has a reaction, or it has a moment about A, it has that same moment about B, but kind of the inverse because it's a reaction.
Exactly. Yeah. So if we can solve for the moment of B, we have our answer. So you do just that. You get your net X and net Y, plug in. Some of these we also need to use some angle and some trig, some SOHCAHTOA. And yeah, that'll get you what you need. And then you should get if you had my numbers, 33.07 Newton meters clockwise. Yeah.
Very nice. I was just checking on the battery. We're looking good. Okay, I'm Andrew Thompson. So we're doing number 9, the big scoop problem. So this is broken down into 3 different free body diagrams for each of the 3 different forces we're trying to solve for. So the first thing looking at this, you're going to want to identify the 2 force members. I don't have the full system drawn out, but all of the cylinders that we're solving for are 2 force members, which means that we can effectively calculate their force using angles, so we can just make a bunch of triangles to figure out their angles. So CG is the first one I'm going to look at. This is a free body diagram of the scoop only. And the reason I chose to do the scoop only initially is because there's only 3 total forces on the scoop, one of which is known, one of which we can eliminate through a moment, and then the last we can solve for. And the last that we're solving for, CG, like I said, is a 2 force member. So we can split this in and find its angle. So the given angle of 45 degrees is going to be for this P value. So if we're calculating the moment about H in order to eliminate this BH component, because this, I think I made the mistake of doing this at first, is not a 2 force member. So we can't, so we can't find BH components, because you could think, oh, you could just eliminate CG and solve for BH. That's not going to work because BH is not a 2 force member, and you actually never need to solve for it to solve this problem, which is actually kind of nice. So once you take the moment about H, you're going to end up with this nice equation here, and you're going to get CG is equal to negative 2.42 kips. And then the next component you can go ahead and solve for. You can actually go either direction, because this part, if I take the moment about I with respect to the whole system, so this is kind of the whole arm, and then this is the scoop down here, it's only going to have 3 total forces again. So you could start with this, or you could start with that, either one. You do have to do the scoop before you do this part right here. So this is going to be the component ABCH as well as the scoop. And so that way, when we include this whole thing as one member, we don't have to worry about internal forces like CD or BH or anything like that, or excuse me, CG. And then we're just going to have 3 forces on it as well. So this all can be broken down into 3 different force members. So doing a moment about B for this system is going to allow you to have just your p-value and just your AD, which is what we're trying to solve for. So here's the moment about B. You'll get negative 3.99 kips. That's with my numbers, of course. And then you're left with the EF component, which we're trying to solve for. So you can take the whole scoop component, the whole arm of this system, so that everything else becomes internal. So the only external forces that we have are at points F, I, and J.
Oh.
Point P is known, or force P is given, and we can kind of do the same method, taking the moment about point I. So kind of the whole method that we're doing here is taking the moment about a point to eliminate an unknown, which is often a non-2 force member, so that we can solve for a 2 force member using trigonometry to solve for its components. Because normally when you're looking at a problem, like for example, if we look over here, you would have AD in terms of the x and the y's, but since it's a 2 force member, we can put it into sine and cosine components, which effectively turns AX and AY into a single unknown, just A, with respective sine and cosine components. So that's the overall approach for this whole problem, just figuring out what to isolate in order to get enough variables to take a moment and then find the unknowns. But I think that about wraps us up. Anybody else have any questions, comments, concerns?
No, I spent so much time trying to figure that out, and that makes so much more sense.
I think it's hard because I think the big realization is the 2 force members realizing, because I was trying to do the sine and cosine components for non-2 force members, and it just screws you over.
Me too.
Yeah. But, all right, are we good?
Yeah.
All right. Thank you.
Do we? I don't know what group we're.
You're 27.